We have been fascinated by the origin, evolution, and nature of the universe for centuries. And although much remains unknown, new ideas and major discoveries made during the 20th century have transformed cosmology. Let's have a look at the history of the universe according to current cosmologists' theories. Cosmic inflation, when the universe expanded faster than light for a fraction of a second, happened about 13.8 billion years ago. What came before cosmic inflation, or what powered it, is currently unknown. However, it is possible that energy during this period was just part of the fabric of space-time. According to cosmologists, inflation explains all aspects of the universe we observe today, such as its flatness or lack of curvature on the largest scales, and it may have also magnified density differences that occur naturally of space's smallest, quantum-level scales, which eventually help to form the large-scale structures of the universe. When the cosmic inflation stopped, the energy transferred to matter and light in an event known as the Big Bang. 1 second after the Big Bang, the universe was an extremely hot primordial soup of light and particles, with temperatures in the region of 10 billion degrees Celsius. The following minutes, known as nucleosynthesis, protons and neutrons collided, producing the earliest elements of hydrogen, helium, and traces of lithium and beryllium. After 5 minutes, most of today's helium had formed, and the universe had cooled and expanded enough to stop further element formation. The universe was still too hot at this point for the atomic nuclei of these elements to catch electrons and form complete atoms. Due to the vast number of electrons, a sort of fog that scattered light was created, making the cosmos opaque. The universe had cooled enough around 380,000 years after the Big Bang, enabling atomic nuclei to capture electrons in a period called the Epoch of Recombination. This had two major effects on the cosmos, with the first being that with most electrons now bound into atoms, there were not enough free ones to scatter light, so the cosmic fog cleared, and the universe became transparent. For the first time, light could freely travel over great distances. The second effect was that the formation of these first atoms produced its own light, and this glow, which is still detectable today, is called the cosmic microwave background, the oldest observable light in the universe. Following the cosmic microwave background, the universe became opaque again at shorter wavelengths due to the absorbing effects of all those hydrogen atoms, and remained dark for the next 200 million years. With no stars to shine, the cosmos consisted of a sea of hydrogen atoms, helium, and trace amounts of heavier elements. Gas was not uniformly distributed throughout the universe, with cooler areas of space being lumpier with denser gas clouds. As these clumps grew, their gravity attracted additional matter, making them denser, more compact, and causing the center to become hotter. Eventually, the centers became hot enough for nuclear fusion to occur in their centers, forming the first stars. These stars were 30 to 300 times more massive and millions of times brighter than our Sun over several 100 million years. The first stars collected into the first galaxies. Initially, starlight couldn't travel far as it was scattered by dense gas surrounding the first stars. However, gradually the ultraviolet light emitted broke down, or ionized, hydrogen atoms in the gas into their constituent electrons and protons. As this process known as reionization progressed, starlight traveled further, breaking up more and more hydrogen atoms, and by the time the universe was 1 billion years old, nearly all of this gas had been transformed, making the universe transparent to light as we see it today. Astronomers in 1998 found that certain bright stellar explosions, called supernovae, were fainter than expected and concluded that this could only happen if they had moved further away at a faster rate than predicted. This has led scientists to suspect that a mysterious substance known as dark energy is accelerating expansion, and whilst future research may yield new surprises, it is currently suggested that the universe will continue to expand forever.